Hey, I'm back. It's a little bit more of you're like, this is kind of weird. He doesn't have any problems on here this time. This time I want to discuss something a little bit different with you. Chatting a little bit when we have a system of equations, we got those two equations where we're trying to find x and y or whatever the two variables are, of which method is going to get me to the best place. So, first one, I'm going to go out of order, I know, is graphing. What am I looking for with graphing? Pretty simple. I'm looking for two equations that have y equals. Why? Because when you're graphing, you want things in slope-intercept form. So if I see two of those y equal equations, if I have the capability, whether it be technology or having a piece of graph paper that I can use, that's going to be the route I typically would go. It's going to be the easiest, okay? The next one that happens probably most often after that would be substitution. Okay, what am I going to be looking for in substitution? X or y equals. So if I have like x equals 3y plus 6, 2x plus 4y equals 10, if I see an x equals or a y equals, it doesn't matter which one by itself, that's going to give me a very quick opportunity to say, hey, this is what x equals. So I'm going to take what I have in the box, plug that in, and all of a sudden, I'm off and running, okay? I get my expression in. Now I can solve for y, then I can turn around and plug that back in for x. I'm just trying to get you thinking right now about, hey, what way can I tackle this, okay? So they're both y equals, we like to graph. If I see an x equals or a y equals, and then something, that's easy to substitute. And our last option then would be elimination, where I don't have either of the two above things. And I have something that looks like this. I don't have y equals, just enough, anything like this. I don't have x or y equals by itself. Nothing's by itself. So this is the one where I'd look and say, hey, can I add straight down and eliminate a variable right away? I know Hardy almost messed up 8 plus 10. I know, on video. That's just a shame. And then I could plug it back into either equation to get the value. So, quick review. Both y equals, we want to graph. We have one x equals or y equals, we're going to try and do substitution. If we don't have any plain old x or y equals, we're going to do some elimination. More on this later. Thanks for checking in.